Hi everyone. The focus for this lesson is electrical driving forces. As always, let's start off with our cell membrane. Now let's familiarize ourselves with a couple terms. The first is voltage of the membrane, which represents the net charge inside the cell. The voltage of the membrane will be expressed in millivolts, which are 1/1000 of a volt. Typically, you'll see the voltage of the membrane written inside the cell, along with the solute concentration written outside the cell. But for now, we don't really need to focus on the concentration of the solute, just the charge of the solute itself. There are two rules when determining the direction of electrical driving force. The first rule is opposites attract. If the net charge or the voltage of the membrane is negative and the charge of the solute outside the cell is positive, this will create an inward electrical driving force. On the other hand, if both the charges of the solute and the voltage of the membrane are both positive or both negative, they will repel each other and create an outwards electrical driving force. Now, let's try 4 examples. Pause the video, think about your answer, and come back. First, let's understand that the voltage of the membrane is negative. Now let's start with sodium. Since sodium is positive, it will have an inward electrical driving force. As for chlorine, chlorine is negative, so it will be repelled and have an outward electrical driving force. Similarly to sodium, magnesium will have an inward electrical driving force. But since it is more positively charged, it will flux much faster than sodium ions. Last but not least are amino acids, which are a compound with a neutral charge or no charge, meaning they do not have an electrical driving force.